Ladies and gentlemen, thank you so much for having me at this wonderful event. My name is Anantshree Chaturvedi. I'm Vice Chairman of UFlex Industries. We are a global polymer manufacturer with roots in flexible packaging. And today I'm here to talk about a topic that I think all of us get to hear a lot about, but hopefully I can give you a little different perspective of this. Before we get into deep dive into the content of what I have to say, let's talk a little bit about what we are actually here to discuss. What we're here to discuss is quite simply a global crisis. The crisis is that plastic is amounting to be a very problematic substance for future generations. Plastic is looked upon in a very negative light, possibly the most negative light any material gets today. And its benefits and uses and advantages are ignored by society, even though plastic consumption and plastic waste are going up significantly. So put the phone on silent. Yeah. Plastic waste is going up significantly. What we are here to do is figure out how do we solve this problem. And just like any other problem, plastic waste, global plastic waste has two issues. One is a stock problem. What do I mean by the stock problem of plastics? The stock problem of plastics, quite simply, is the plastic that exists in every format, whether it's flexible packaging waste, whether it's injection molded waste, whether it's automotive parts, whether it's electronics and plastic electronics that get discarded and don't get recycled, which are a combination of plastic and metal, and sit in people's basements or sit on people's shelves unused for years. These are all components of the stock of plastics, the stock of polymers that have built up over the course of human history since when these materials were invented. The second part of this whole aspect is the flow problem. What do I mean by the flow problem? The flow problem is new plastics that get created every day by manufacturers like ourselves and thousands, tens of thousands of global manufacturers that participate in this industry, which is an essential resource to serve food security globally, to make sure that products go from an inception creation stage safely to their final destinations and then safely to consumers' homes. And last but not least, it ensures global supply chain that works actively to supply products in different parts of the world with different conditions, but with the right packaging that allows that product to get there in a safe, consumable way, whether it's for food consumption or whether it's consuming a product like a cell phone or a computer. So polymers provide this essential service to the world, and that's the flow problem. The only way to solve the plastic crisis is to solve both problems. It's to solve the stock problem and the flow problem. And that's much of the same when it comes to greenhouse gas emissions or population, or if you see, global ecological lack of controls for animals and their sort of breeding. All these problems have the same basic component. There's a stock of emissions, and then there's a flow of emissions. There's a stock of population that exists on Earth, and then there's a flow of human population that's being added. There's a stock of herds of certain animals that exist in certain environments that cause that environment to be either a forest or a desert, and then there's a flow of those animals that come out as well. So all these global problems lead to the ecological disasters that we're facing today. But the good part about the plastics crisis is it's a solvable crisis. How do we solve it? Is we have to attack this problem from both sides, the stock and the flow. We go to my next slide, which will explain us how UFlex is addressing this problem. So if you look at how we came about this problem, is we wanted to understand how do we get the flow of plastics to be part of the circular economy, while as doing things with the stock so that the stock gets reduced and essentially becomes a part of the flow. How we did this was by 4 components, which we call Project Plastic Fix. And the reason why we call this Project Plastic Fix is that projects start and projects end. And we believe the plastic problem will be resolved. It'll take time. It'll be resolved in the next 15, 20, 25, 30 years, whatever pace we decide to resolve it and whatever priority we give it. But it is a solvable problem. Why it is solvable is because you can do these technologies to effectively solve this problem exist today, and simply we need to put it into circulation. So let's talk about how we solve the stock problem. The stock problem can be solved by the first 3 aspects of Project Plastic Fix, which is pyrolysis, which most of you are aware of, which is chemical engineering to convert plastic waste into through an anaerobic method into fuel. Our method has no emissions, and we recycle all of our inputs and outputs for this particular method so that we have zero impact. It's a net zero process for us. Different companies do this in a different way, but that's the way we see the most effective way to do this. Pyrolysis really is something that's more valid for countries and nations that have an energy crisis or have a lack of energy infrastructure. This can be a novel solution to provide extra energy into those environments. The second part, which is really our main invention when it comes to this, is our form of MLP recycling waste, which is our mechanical recycling process. We actually won an award in Davos in 1995 for inventing this very novel method for recycling all kinds of plastic waste, but especially multi-layer plastic waste, which is notoriously hard to recycle. Our process, has an extensive amount of technology attached to it, with a combination of sensors, infrared scanners. We're also deploying some, basic machine learning AI to help us sort. And of course, we have a series of cameras and other kind of gauges to make sure that this waste gets sorted and it becomes 10,000 different novel products, really whatever you would like to make from a plastic strength perspective. The third aspect, which is what we're very proud of, which is actually developed in this facility that I'm speaking from today, which is our facility in Kentucky, is our Celsius, or our 100% PCR post-consumer recycled waste content films. The novelty of this product is that we make the exact same product with very little wastage, very little degradation. Nothing needs to be done from a consumer perspective or from a customer perspective to switch to this material. It's a seamless transition, and it's 100% cyclical waste to wealth aspect, because it's we're taking product, we're making it, we're supplying it to the customer uses it, goes to the end consumer uses it, and it comes back to us, and we simply input it in again and again seamlessly. And those are the 3, I would say, solutions under Project Plastic Fix, which solve the stock problem of plastics. Now, let's go to the flow problem. The flow problem is new plastic that's being made today. How do we solve that? And the way we came up with the solution was, and a lot of other players, a lot of other companies are also doing this, which is we developed a bioenzyme that degrades essentially this plastic into biomass, basically sugar or glucose, and it's it's done, and we can do it Last study that we had about a 40% degradation rate in the first year, which leads to a sort of 2.5-year full 100% degradation cycle. We're actually cutting that down, and we're very confident we can bring it down to about 3 to 6 months if needed, or even lower, depending on, of course, what the customer wants. The key of this bioenzyme is it can be tailored to the product that you're packing in it. So obviously, if you're packing potato chips, they will have a much shorter, let's say, shelf life than, let's say, you are packing a charging wire for an electronic device, which, if it's packed in a plastic pouch, or it's the plastic pouch is within the paper box container, it needs to degrade in a certain different rate because it might sit on a certain shelf longer. That's how we are solving the plastic problem. Now let me go a little bit more into detail of some of these solutions. Let's go to the next slide. Our recycling solution is really our novel breakthrough, and you can see some of these products displayed. But our aim with this solution is very, very simple. Our aim is not so much, we don't want to convert into a plastic recycling company. We are a material science polymer manufacturer. And for us, we want to stay very, very close to our core competency, which is making new materials for the earth. Our aim for this is to encourage other entrepreneurs who can see an opportunity that today is completely wasted, which is essentially plastic that's used once, single-use plastic, or even multi-use plastic, and then it's discarded. We want to encourage entrepreneurs as many as we can to get into this recycling business and create products that come out of recycled plastic resin with pride, and which are tailored to their local economies. So, obviously, if you are living in, a cold environment, you will not have much use for recycled plastic making fans. But you might have a use for recycled plastic making, heaters, or some kind of mesh coil construction material for insulation. You might, need it for being a wind stopper under doors. So obviously, it applies very, very distinctly locally, and that's where the entrepreneurship part comes into this, because the entrepreneur will have that hold of local knowledge, will have that hold of local trends that they can tap into. And if if the last couple of years have proven anything, the pandemic has proven that we live in a globally more local world, and the world is not as flat as previously perceived. So having a local understanding and being a local manufacturer matters, especially in today's day and age, where logistics are probably one of the most difficult things to deal with. Next slide. Our pyrolysis solution is a very novel solution which uses basically multi-layer plastic waste, or any kind of plastic waste, and then creates energy out of it. We've used it to create all kinds of different liquids, including low-end diesel products, and these are used to then power electricity and power factories. In fact, some of our factories do run on this kind of setup where they're using the waste that's not only being produced by them, but also coming in greater and greater quantities from the outside environment. And here you can see that in both these solutions, you're solving the stock problem. If you look at pyrolysis, or you look at recycling, which is the last slide back, last slide back, So if you look at that, both these solutions are solving the stock problem, the problem that is there today. That's what we're trying to solve. And that's a very effective way of solving it. Next slide, and next slide. Here we have our Celsius product, which is our 100% PCR, post-consumer recycled waste product. And again, the novelty in this product is not only that it is the world's only Kingfisher rated, certified, 100% recycled product, but the beauty of this product is that it runs seamlessly like its fossil fuel counterpart. And that's very important. A lot of times when you are dealing with plastic waste solutions, if they involve a significant change when it comes to how your customers are using this material on their machines, if they're using, if they have to change their temperature or pressure parameters, if they have to change their stretching ratio parameters, if they have to change any kind of ink, adhesive, or any kind of change in their production cycles, will cause great pain, and bigger than that, will cause great resistance when it comes to any kind of solution being successful. We took that into account. We made this product as seamless and as foolproof as possible so that there is very little chance of this polymer behaving in any other way other than a normal virgin grade resin. And that was what the key was in this solution. I'd be happy to tell you this was the only, we have done a few case studies for this. Most of them are very easily searchable online. The biggest thing we've done is with a label manufacturer called UPM, and we've never had a situation, at least as far as I know, where I have actually got customer orders when I'm running trials or running an experiment for a material. But this was such a novel product that for the first time ever, I could see customers were interested in buying the very first batch that came out. And that's a testament to where the world is headed, where the plastic problem is being actively solved from not only a social and a sort of future generation consumer perspective, but companies today are solving this problem for themselves so that they can have an effective, environmentally sustainable green future. And this product is a testament to that. Next slide, please. And then last but not least, we talk about sustainable materials. There's many different kinds of sustainable materials that we've developed, which are listed here, like our paper-based tubes, which are our makeup tubes, or water-based printing inks, our cylinders, our solvent-free inks. It's not only solving the material problem, it's also solving the materials that go with the base material. So if plastic is the base material, yes, you can solve the plastic problem. But if you're using an adhesive that's harmful, or that's high in emissions, or is even using layers of plastic, well, you have to get away from that. You have to get away from using that and going towards a water-based solution that can be easily treated, and the water can be recycled and reused. I mean, for us, we're looking at this problem holistically, from beginning to end. So for example, our plant in Mexico that is going to make PCR resin has a very, very complex and effective water recycling strategy, because we'll be washing, the incoming waste, cleaning it, sorting it, and making PCR film, a Celsius film, out of it. But one of the things that we paid close attention to was how are we going to make sure that the water we take into the facility is, and the water that's going out of that facility is as good as the water that we're taking into the facility. And it was a very, I would say, a complex challenge to do that. But we do have solutions now where we have a treatment center and the right technology to be able to do that. Most of the time when you visit recycling facilities, you'll see a lot of water wastage. And that's us, that's then setting up for the next problem. You solve the plastic problem, and then you're consuming 6 times more water than you did 10 years ago. Now you have a new problem to solve, and that's not what we're going for. Next slide, please. And the last is our bioenzyme problem. Now here is, or a bioenzyme solution. Here is our novel solution that takes into account how do we solve the flow problem. The flow problem is plastic that's made today, new today, and consumed today. So every bit of plastic that you consume today, whether it was the little toothpaste tube that you used in the morning for your toothbrush, or whatever container your lunch came out of, whatever container your dinner came out of, that cup of coffee that you had from a barista, which used some kind of plastic, whether it's, even if you're not using it, you're not touching it. Most of the time, most restaurants have things delivered in large bulk plastic bags. So there is an element of plastic there, even if we don't see it. How do we solve this problem? Again, to solve this problem, the best way to do it is to make it as less effort from the end consumer as possible. A lot of times in our culture, and especially in the way the plastic problem is being solved, we tend to put a lot of emphasis on the end consumer solving this problem, the end consumer sorting out plastic and taking out 2 hours of their week to sort out plastic, and making sure that everything is in the right bins and everything gets deposited in the right place. Truth be told is, if you look at global recycling rates, I think Sweden has the highest recycling rate at about 32%. I think maybe it's gone up a little bit since the last time the survey was done. The survey skipped a year in the pandemic. The US has an average recycling rate of 8 to 12%. So you can see most consumers are not willing to put in this effort. There are some consumers that will, and we respect them, and they are leading the way forward. But even in places like Europe, where waste will not be picked up unless it's properly sorted, more times than less, mistakes are made, because also consumers simply don't know what polymer is what, and what those labels and those triangles in the back of packaging means, right? So how do we make this seamless, that if a plastic product does end up in the waste stream, and God forbid gets thrown out in the road, or it's consumed and discarded in a waste paper basket that no one cleans out for a year, how do we make sure that that does not add to the stock problem? And that's our biodegradable solution. Our biodegradable solution will, in normal soil deterioration conditions, soil biodegradable conditions, will, as soon as it's coming in the right element with the right environment, will start breaking down the molecular chains and will convert it back into completely harmless components. Another differentiator that we have is our Viome process, which is our evolution of plastic recycling and plastic waste, where we're using, taking traditional properties of film and enhancing it to use less plastic, but while giving it more strength, more barrier, and a higher yield. This is a novel solution that will be revealed in the next few months to come. And it's a very, very promising next generation technology that we've been working on. And you can see all the other initiatives that we're doing to solve this problem. But in conclusion, I'd like to say that we all must remember that the plastic crisis, the plastic problem, the plastic demise that is leading to us worrying that we are going to convert this planet into a waste pile is not the truth. There are technologies that exist today that can solve the plastic crisis. These technologies are live, they are usable, they are scalable, and they are affordable. If you look at the cost benefit of using these resins, eventually this will actually become, these novel technologies will become cheaper and more easy to use than even fossil fuel-based polymers that we are consuming today. So all these technologies exist today, and they are designed from the get-go to be scalable, to be a global solution provider. So the planet will not be covered in waste, especially plastic waste, but really it's up to the effort that we put today in the planet. And my mother always called me an optimist, so I will say that I'm optimistic about us coming together and solving this problem as a society, as human beings, and as someone who wants to leave a good legacy for future generations to come, where the solutions and the novel ideas we provided led to a better future for them, rather than the future that is outlined today. Last slide. That's my presentation. I'd like to thank you very much for your time today. And I would be happy to take any questions through the forum. My email, I'm sure, is in the speaker list. Thank you very much.